Hello, my name is Ed Browl. I'm from the NASA Langland Research Center, and I've been the principal investigator on developing a laser remote sensing instrument for measuring water vapor profiles and aerosols and clouds, primarily from aircraft. And this poster deals with the application of this instrument flying on a number of different aircraft over the last 15 years in studying how high-resolution water vapor data that can be obtained with such a laser system can be used to better understand and forecast track and intensity of various hurricanes that we've been studying. We've flown in a number of different hurricane missions and severe storm missions over the last 15 years, as I mentioned, and these panels show different sampling that we've done from an aircraft in looking at water vapor around, for example, Hurricane Erin here and Hurricane Bonnie, and working with the FSU modeling group. They've been able to take the high-resolution water vapor data from the laser instruments and show how, if you had that information, you could better predict the track of the hurricane and also the intensity of the hurricane, where you're trying to predict it and forecast it several days in advance. We've also done and shown how water vapor is very important in the initiation of severe storms over land, such as in the Texas-Oklahoma area, where we have a dry line along which you have very large moisture gradients. And if you have the kind of information that we obtain from the aircraft, it helps to better predict when the severe storm is going to initiate and how strong it would be. We've also looked at the influence of Saharan air coming off of Africa and how that impacts the genesis of the tropical storms that lead to hurricanes. And if you have information on the water vapor and the particles that's in the Saharan layer, that helps you to better predict whether that the tropical storm is going to intensify or not. Most recently, in 2010, we conducted some additional flights over Hurricane Earl, which is shown here, with respect to the water vapor that we got with the laser, looking down in the eye of the storm as well as outside of the storm, and how the information on the particles and clouds along with water vapor can be used to help us better forecast the trend of the storm in the future. And so we hope to continue to use this type of instrument from aircraft and ultimately from space in complementing what's being done with passive instruments to better forecast severe storms.